Alright, so we're going to look at a certain application of using law of sines, or even law of cosines we'll see, where we have what's called the ambiguous case for a triangle. So when we have information in this order, where it's side-side angle like that, we have potential for two triangles, one triangle, or no triangles to exist. And so we have to be a little bit careful as we do this. So that's the relationship. What we can think about is you can imagine that this has some flexibility. This angle is not fixed. This side length is not fixed down here. And this angle is not fixed. And so I could swing this thing around and potentially make another triangle. And so that's what makes it ambiguous, is we don't know if that triangle exists or not as we move forward. So if you remember in geometry class, you couldn't use side-side angle as a congruence postulate for triangles, and this is why. So this is the algebraic kind of reasoning behind it. There's other options where we have a side that isn't long enough, and so we kind of have two ways that we can go about this part. Is we can memorize some restrictions on our side length and stuff, so we could try to figure out basically this height of this triangle, and if A is less than that height, it's not going to make a triangle. If A is larger than that height, it could potentially make two. And if A is equal to that height, then you just have a right triangle. The tricky thing is you have to find that height every time. So another option is to just kind of solve it and see what happens. So that's our geometric. Algebraically, we just can kind of figure out what it should be and see if it makes sense numerically. So if we took the example above, which you know is not going to work because that side 4 is too short, and we solved it using the law of sines. So sine of 40, sine of b over 16, and then we would get sine of b is 16 over 4, which is 4, sine of 40. We get sine of b is 2.57. Well, the largest sine value we could ever have is 1. So there's no angle that exists that's going to give me 2.57. If we try to put it in a calculator, we get an error. So there is no triangle that's going to make that work. So we get the same answer as above, where nothing works, but we have an algebraic reason for why. Again, these are all the situations that we could look at, and these are the restrictions on the sides in terms of how it relates to the height. But another way to do it is just to solve it and then think about what your answer is, and that will be just as effective as looking at these pieces, and maybe you can remember it more down the road. So let's look at some of these and let's see what happens. So if I have A, B, and C and I label my pieces, again, I know it's potentially ambiguous because it's angle side side, and so I have to worry about 0, 1, or 2 solutions. So if we just solve this thing out and we set up our law of sines, and I'm looking for angle B, and so I work through it and I get that 1.2 is sine of B. Again, just like the one before, my largest sine value is 1, which means that this thing is going to have no solutions. If I got a sine value of 1, then I'm only going to have one solution. And we'll see what happens if we get a sine value that is not 1 or bigger than 1 in a moment. So there's no triangle that's going to make this work. It's not possible, geometrically possible, and that's the algebraic reason right there behind it. If we look at another one, so here is, again, side-side angle, right? And we're trying to solve for it. So if I set up my law of sines, I work through it, and I get sine of C is 0.57. So angle C is going to exist. So there's at least one solution to this thing, potentially more than one. And so as we do this, we're going to have to kind of evaluate what that means. And we have to go back to kind of how this works within our unit circle. So if I take the inverse of 0.57, I get about 34.8 degrees. So that's one of my answers. Now, but we know though on the unit circle, if that's 34 degrees, I'm just going to leave the 0.8 off as we kind of go through this. If we go straight across, remember sine is my y value, that angle over here is also going to have the same sine value. So if we put our reference angle in of 34 degrees and I rotate across, that's roughly 146 degrees. And so now the question is, both of those angles have the right sine value, but are they going to fit in my triangle and make it make sense geometrically? And so if we try it, 34.8, right, that's going to be okay. 20 and 34.8, there's plenty of room to make that angle. They just had to add to 180. And for the next one, right, 20, 146, and then the question is that angle up here, angle B, going to work? Well, 166 is going to leave me with 24 degrees for angle B to work. So that is going to work, and I'm going to get another angle there. So these are the two triangles that would work, and I have my two solutions here. So That's again my ambiguous case as we work through it. Another way that you could go about it is not necessarily easier, but it'll pop out two solutions as you go through it anyway. So if we look at the law of cosine, so I start with a triangle just like you did before, and we set it up. So I'm going to give in side-side angle. There it is. There's my angle. There's my sides, and I'm looking for angle A, or sorry, side A. And I use the law of cosines. Now, why this is going to be trickier is I'm going to have to also use the quadratic formula. But if I use the law of cosines and I set it up, so 6 squared is 10 squared, minus 2 times A times 10 cosine of 30, right? And then cosine of 30 is going to give me a value that I can plug through my calculator with. I bring some stuff around, so A squared minus 17.3a plus 64. That is a quadratic, which means we can solve it with the quadratic formula. So to do that, we set it up. That's the b squared plus or minus square root of, negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I get my answers, the plus or minus of those. I get two things that we can solve. The a is either 11.95 or a is 5.35, and the or part is what makes it ambiguous. So I could also see if I could get some negative solutions in here to have no real solutions, or if this thing popped apart, or sorry, the discriminant was 0, then I'd have my one solution. So however you go about it, geometrically, a lot of sines, a lot of cosines, you just have to be aware that when you have things as your angle, side, side, you potentially have 0, 1, or 2 triangles to look for.